Some time ago, I think it might have been about 20 years ago, somebody came out with the assertion that with software quality management, we're not trying to achieve perfection or perfect quality. What we should be looking at was good enough quality. And they had a good point. Rather than spending a whole lot of money trying to achieve levels of quality that were not required, we should figure out what level of quality was required and go for that. This was after it finally was admitted that it was unlikely, if not impossible, to produce a completely error-free piece of software. It just wasn't going to happen. So rather than try to aim for the whole idea of zero defects, we should aim for what was required at the time. Now that's cool, but we get into the tyranny of large. That is, if 1 in 10,000 defects, 10,000 lines of code, 1 defect in 10,000 lines of code, is that good enough? Well, possibly, but if you have 10 million lines of code, and some systems these days do get up to 10 million lines of code, now you're dealing with 1,000 defects. Is that good? Is it good enough? Well, it depends on the defects. But it sounds horrible. I mean, 10 million lines of code, you get that in, say, the average air control system, or I think somebody pointed out that software in the control systems of your passenger cars now is about 10 million lines of code. So there's probably about, I don't know, I mean, 1 bug in 10,000 lines of code is considered pretty good. 1 bug in 1,000 lines of code is more like commercial realism, but 1 in 10,000 is a pretty good level of software defect density. So that, as I say, produce about 10,000 bugs in your car. Well, as long as it doesn't cause my car to crash or malfunction, it's probably acceptable. What you have to do in these circumstances is take a risk-driven approach, right? So what are the most common defects? Where do we make the most types of mistakes? Which defects are going to cause the most problem? You know, what's the impact of a defect? What functions are critical to success, and what failures are likely to be, what failures will compromise the product entirely? And I guess the other question is, well, how much time can you afford to spend fixing these things?